Assalamu alaikum students, welcome to our channel. Today we are going to start discussing some questions from different topics. The first topic is quadratics. Let's see what they ask in this question. Find the find the set of values of k for which the line 2x minus 1 intersects the curve is at two distinct points. Okay, so first thing first, what think about this condition. Yes, they said mention here two distinct points. As we notice this condition, the very first thing that brings clicks to my mind is called discriminant, which is b square minus 4ac. And that discriminant must be greater than 0. Why? Because we have two distinct points. Okay, for the discriminant, I must have A, B, and C. But the question is, these are can be extracted from the quadratic equations only. How do I get the quadratic equation? Yes, it's very simple. What we do, we solve the two equations simultaneously. How can I? Let's see. I'm going to substitute this value of x over here like this. X squared plus kx plus 3 is equals to 2x minus 1. Let's bring the two terms on the right to the left hand side. What happens? The signs are going to change. This is minus 2x and this is plus 1 equals to 0. Now, let's collect the identical terms. We have ax and 2x are the like terms. 3 and 1 going to be added. It becomes 4. From this quadratic equation, a represents the coefficient of x squared, which is 1. B represents the coefficient of x, but we have another x. So let's combine the two numbers and write them in B. Similarly, the C, the remaining, which have no x, which have no x squared, which is 4. I write 4 here. Now I'm going to substitute all three values of A, B, and C in the discriminant, and the condition says that D is greater than 0. D stands for B squared minus 4AC must be greater than 0. Let's substitute the values of A, B, and C. The B is K minus 2 squared. Then we have A, then we have C. So let's open the bracket with the help of the identity. Is going to be k square minus 4k plus 4. And this is going to be negative 16. Simplify it further. It's going to be x square minus 4k minus 12 is greater than equals to 0. Let's factorize the equation. So for the let's break the middle term. It's going to be k square minus 6k plus 2k minus 12 greater than 0. Let's take common from these two. It's going to be k and we have k minus 6. From these two, it's going to be plus 2 as common. Inside the bracket, it's going to be k minus 6. So what we have k minus 6 and k plus 2 greater than 0. Now, the important discussion. How we can write the inequalities? How do we write the inequality? Let's look at carefully on the left hand side. I'm going to write down. So if I take the value of k, I will get k is equals to 6. If I get the value of k from here, I will get k as minus 2. But the problem is we have an inequality. So we must write in the form of the inequality. So what we do now, before this, let's recall. We have 6, we have negative 2. So this represents which number is bigger, which number is smaller. So as you see, 6 is a bigger number and minus 2 is a smaller number. So inequality, for the inequality, you must remember two-line statement. What is always same with the big, change with the small. Your number k, your k value say is big, therefore we write the same inequality with 6. Minus 2 is smaller than 6, therefore change with the smaller number. It's going to be negative 2. So these are the two possible results or the range of the values of k for which the line is intersecting the curve at two different points. So I hope you have noted down. Please carefully read down. So I'm going to move on the next question. So let's take on the next question. Yep, circular mirror. In this question, they mention here that we have a diagram. Yes, we have a sector. As you can see, AC is an arc of a circle with center O. It means OAC is a sector with center O, right? As you can see, the angle is given in radians. Similarly, as you can see, the length of OC is 6, therefore the length of OA will be also 6 because it's a radius line. Now they are looking for the area of the shaded region. So simple plan is get the area of the triangle first and then subtract the area of sector. You will get the area of the shaded region. But the question is for the area of the triangle, let's calculate the length of BC first, which will be the height of the triangle as well. But if you look at carefully the triangle ABC, yes, triangle ABC. I'm going to draw here a triangle ABC separately, so it helps me you to get an idea. This is the triangle ABC. OBC, sorry, OBC, yes, triangle OBC. This is O, this is B, this is C, and this is the angle given, which is pi over 3 radians. As you can see, this is the length 6 centimeter is also given. So if we follow this right angle triangle according to this triangle, your BC is going to be the opposite. Yes. And your 6 is going to be adjacent. Let's think about a trigonometric ratio. Yes, opposite over adjacent. Yes, very good idea. Going to be tangent. So opposite over adjacent will be called tangent theta. So the theta is going to be pi over 3. Yes. The opposite is not given, which is BC, which is the height of the triangle as well. And the base or the adjacent is 6 centimeters. Remember, your answer should be in root 3, means no decimal acceptable. So root tangent pi over 3. Pi over 3 represents the 60-degree angle. And tangent 60 is always equals to square root 3. Remember, when you use calculator, tangent angle is in radian. That's why your calculator mode should be in radians. On the top of the screen of the calculator, there should be an R, which tells you that your calculator is in the radian mode. So you're going to have root 3. Since I'm looking for the length of the BC, I will move the 6 over there. It's times with the root 3. So BC is going to be 6 square root 3, which is also the height of the triangle as well. So let's get the area of triangle. Area of triangle OBC. Angle OBC. 1 over 2 base, which is OC, 6 centimeters. The height BC we just calculated here is 6 square root 3. By simplification, I will get 18 square root 3. This is the area of the triangle OBC. Let's find the area of sector. So area of sector, and the sector is OAC. OAC. Let's recall the formula of area of sector. It's half r square theta. Remember, your angle should be in radians and the angle is pi over 3. Radius is 6 centimeters square. That is pi over 3. So in this case, it's going to be 6 pi. That's the area of the sector. But I'm looking for the area of shaded region. Area of the shaded region. How can I get this? Yes. Area of triangle, which is 18 square root 3 minus area of sector. Yes, if you notice, they mention here that your result should be in terms of pi and square root 3. Yes, I can see square root 3, I can see pi here. So my answer is okay. But if you want, you can simplify by taking something common, which is 6, which is, I repeat, not necessary. It's going to be 3 square root 3 minus pi. This answer is acceptable. This answer is also acceptable. Both answers are acceptable. It's up to you in which format you may write. But if you write your answer in decimals, you will lose some marks. Definitely, they are not going to cut the whole mark, but 1 mark will be lost by you. Why? Because they mentioned here, they instructed you that your answer should be in pi and square root 3. So you must follow the instructions carefully. Please note it down carefully. So I move to the next question.